Okay, this is worksheet 1, or 11. I'm just going to go quick, kind of explain how I got these answers. Here I wrote down the amplitude was 5, period was pi, 2 pi divided by b, and then phase shift is the opposite of c over b, so negative pi over 2. So here's the phase shift of negative pi over 2. I know that it's going to take pi units to get to here, so if you take negative pi over 2, if you aren't sure how to do that, you're doing where you started, and this period has to be pi. Alright, pi, so you're going to add pi, which is 2 pi over 2, and so you know you're going to end up at pi over 2. Halfway in between there is where the 0 is. Halfway in between these is the minimum and the maximum. So that's at negative pi over 4 and pi over 4. Okay? Number 2, amplitude is 1, but there is a negative sign in front of there, which means we are going to flip it. The period is 2 pi, and then the phase shift is negative pi over 2 over 1, so just negative pi over 2. So here's my phase shift, negative pi over 2. I complete one cycle in 2 pi units. So again, if you take negative pi over 2 where you started, add your period, which is 2 pi, or 4 pi over 2, that's what 2 pi is, I get that it should end, it's the one cycle at 3 pi over 2. And so halfway in between there again would be pi over 2, halfway in between each of these is pi, and halfway between those two is 0. So it's going to have a minimum at negative pi over 2, intercept at 0, maximum at pi over 2, intercept at pi, and then back down to a minimum at 3 pi over 2. Alright, number 3. It's a tangent, so there is no amplitude. Remember, there's only an amplitude for sine or cosine. The period is the normal period of pi for tangent and cotangent divided by b. b is 1/2. It's x over 2, which means the coefficient of x is 1/2. So pi divided by 1/2 is like pi times 2. So the period now becomes 2 pi. So there's no phase shift, which means I keep that 0, 0 point. Because of the negative, it means it's reflected. So now instead of being an increasing graph like tangent normally is, it's going to be a decreasing graph. And then because the period is 2 pi from my intercept, I have to go pi units out this way and pi units that way to make sure my period is 2 pi. And then that pattern would continue on. Okay, the secant. To graph the secant, think about cosine. Now the amplitude of secant is none, but the cosine amplitude would be 3 units. So this is going to go up to 3 and down to negative 3. Okay, the period is 2 pi divided by b, and again, in this case, our b value is 1/2, so I get a period of 4 pi. And then the phase shift is the opposite of c, so that's going to be pi over 2 divided by 1 over 2. And so when I did that, I just multiplied both the top and bottom by 2, so they dropped out, and I got pi. So the phase shift is pi, so I go pi units over to start my cosine. The amplitude of cosine was 3, so it's going to go here, come all the way down, get back up. The period was 4 pi, so if I started at pi, I have to complete that cycle in 5 pi, because it's 4 pi units to get to there. And so once you have that drawn, then wherever you have an intercept, which is at 4 pi, 2 pi, 0, 6 pi, those would be vertical asymptotes. And then you just take these points and you flip them up. You're just taking these because it's a reciprocal function. This would be down here, this would be up here. So the darkened in pieces is my actual answer of the secant. Alright, number 5. Cosecant, so that means there's amplitude of none, even though the sine of that will have an amplitude of 1. Period will be 2 pi divided by pi, divided by that b value. So that will be 2, and the phase shift is opposite of c over b, negative 2 over pi. So I don't really know what negative 2 over pi is, but I know it's over here. That's the phase shift. I drew in my one cycle of the sine curve, and then to label it, I have to look at this and say, all right, if this is negative 2 over pi, if my period is 2, this is going to be negative 2 over pi plus 2. That's all I'm going to do. I don't have a calculator to figure out a decimal of that. So that means halfway in between will be negative 2 over pi plus 1. That's what I labeled right up there. And then half of that would be negative 2 over pi plus a half. I put that right here. And then negative 2 over pi plus 1 and a half would be right there. So because the period is 2, I just added a half to get to the max, added another half to get to my 0, added another half to get here, and then added another half to get there. And you don't need to figure out what those are, just label them as where you started plus a half each time. And then wherever there's a 0 again, which is at negative 2 over pi plus 1, negative 2 over pi plus 2, at where you started at negative 2 over pi, those would all then be vertical asymptotes. And then again, this piece is my answer. I'm just taking those and flipping them, taking the reciprocal of those pieces. Okay. All right, number 6. Number 6 is a sine curve. Amplitude is 3. Period is, don't worry about the negative here. We're going to worry about the negative when we flip it, which I think I did not flip. So my answer is wrong, actually. You do have to do a reflection. I forgot to do that on my answer key here. So even though the period isn't affected by this, the period is still 2 pi divided by b. So it's 2 pi, the period is still pi units. So it is going to take pi units to complete the cycle. Phase shift is going to be the opposite of c over b. So the opposite of c divided by b is going to be pi over 4. So it does get shifted pi over 4, and the vertical shift is negative 2. So I do know it's going to go up to 1 and down to negative 5. But because of this negative, you either, technically, you got to think of it as it's flipping this way over the y-axis when the negative's in with the x. But because it's odd, you also can think about it could also flip over the x. Because it's odd, it doesn't really matter which way you flip it. So I would probably, so I don't have to go over it on this side, just say that it's still going to be here, but now it's going to come down to 5 first, then up to 3 and down. Again, because it's odd, it really doesn't matter if you flip it over the y or the x. And so that's probably what I do. Is just flip it over the x-axis. All right. Number 7 is a secant, so I'm going to graph a cosine. There is no phase shift, so that's why it started here. There was a vertical shift of negative 3, so it went down negative 3. The amplitude was 7, so it's got to go down to negative 10 here. And if I go 7 units up from that, it will get me to 4. So the 4 was here and negative 10 was here. The period is 2 pi divided by 2, so the period is pi. So it is a cosine, so I start up here at 4. Remember, it's 7 units up from that y negative 3 axis. Comes down, comes back up in pi units. Halfway, it's going to get a minimum at pi over 2. Halfway between there at pi over 4, you had a 0, and at 3 pi over 4. So those become vertical asymptotes. And then again, I just flip this piece, and up here I flip those pieces. And I did label one more period so that if I was going, if this was at pi over 4, then this would be at negative pi over 4. I'd have another vertical asymptote. And then the last one, it was a cotangent. Cotangent's a decreasing graph. There is no amplitude. It does mean it gets stretched by 3, but you don't have to worry about that. In a graph, you just need to know the normal period is pi, and you're going to divide that by 4. So normally at 0 is an asymptote for cotangent. So that's going to stay the same. So cotangent has an asymptote at x equals 0. There's no shift, so that's going to stay there. I know that the period is pi over 4, so I draw in my other asymptote at pi over 4. Halfway in between is where the intercept is going to happen, and that's pi over 8. And so then I drew my graph, and that pattern would continue. So that's the graphing worksheet, worksheet 11.